Hello, so today we are doing this problem called longest palindromic substring, and the problem says we have a string S and we want to find the longest palindromic substring in S. We may assume that the maximum length of S is 1000, and so we get a string like this one, BABAD, and the output should be the longest palindromic substring of it, which is this one. And a palindrome is just something that if you read it from one side and then read it backward, you get the same string. And so we want the longest in substring that has that property in this in whatever input we have. So how can we solve this problem? So let's just take this one as an example, and let's think about. First, let's just think about a brute force solution that we can apply here. How about, for example, just one thing we can do is just generate all substrings. So the first brute force we can think of is just generate all substrings and check palindromes of them, and then return the longest one, right? This is the first brute force that comes to mind. The other way we can think about this is, okay, so we can do this certainly, but this appears to be expensive, especially if the string is too big. But another way we can do it, let's just arrange our brute force in a way that it's likely to return the result faster, right? So how can we do that? So one way we can do this is go through all the possible length instead, not the substring, all the possible length of substrings from highest to lowest, right? So first choose the entire string, which is the entire length. So for example here, this one has length 6, right? So length is 1, 2, 3, 4, 5, right? So go through the string of length 5, check if that palindrome. If that is palindrome, then that certainly is the longest one, because that's the highest length we can achieve. Otherwise, if that's not the case, so first check 5. If it's a palindrome, then return that. Otherwise, check all the substrings of length 4, which are here. So the substring of length 5, that's just, in our case here, that's just this one. But of length 4, that can be either this one or this one, right? And if we check, both of them are not palindromes, right? So we go check the next lowest length, which is 3, and then we take those of substrings of length 3 here. We have this one, we have this one, and we have the middle, right? And so looking at this, we can see that this one is a palindrome, right? This one is not, but this one is. This one also is a palindrome. So you can see we can find those two and just return immediately, because we know because of the way we traversed the length, we know for certain that this one is the longest palindrome. And so it's kind of brute force, but it allows us to find the solution faster. So let's just code that. So let's say n is the length of S, and we need to go through the length from highest to lowest. And so to do that, we can just say in range of n, but do that, reverse it, so that we can get first n minus 1, and then n minus 2, and then n minus 3. So this here in Python just reverses the list. And then now we are going to check all the substrings. And so how can we check that? Check all the possible beginnings, right? So all the possible beginnings are all i's that are in the range this minus length, right? Because if it's after this, then it doesn't have this length for sure, right? So check all the possible starts for this length, and then construct this substring that starts at this one I and has length. So that's just I, and ends at I plus length. So this one we check. This one is the substring of length, this length here. And so the first one that we find that is a palindrome, we just need to return that, because according to our solution here, that's the longest palindrome. And so the way we check that is a palindrome is just a string that so S is a palindrome if S is equal to the reverse of S, right? That's the definition of a palindrome. And so in order to check this in Python, we can just use the same thing we used here for reversing a list. A string is a list of characters. And so get the reverse and do check if it's equal, that means it's a palindrome. If palindrome is palindrome. And then if it is, then we can just return the length, because we can return that string because we know that that string is the longest palindrome. And pretty much that's it. If we didn't find anything, we can just return an empty string. Okay, so that's pretty much it. Let's submit. Okay, so we have one character here that is wrong. Let's see. So A, we have output nothing. We should have outputted at least S of, well, we can just return S actually, right? Because if we don't find anything here, no, maybe the string doesn't have a palindrome, right? So we can just return, actually, let's see, where did we make a mistake? So yeah, the length here, it's +1, because if I do just I plus length, it will stop at I plus length minus 1 because of Python's numbering. But if I do, but to get until I plus length, I need to do +1. Okay, so that solution passes. So you can see we just used the brute force, but with a clever ordering. It's kind of a greedy solution because of the way we traverse. We are certain that the result that we have is the longest one. The second solution we can apply here is dynamic programming. So dynamic programming has, whenever you see a problem that asks for a longest thing that has some property, you need to directly think of dynamic programming. And so with dynamic programming, we need to do a couple of things. So what is the goal function? What is our base case? And we need to find our recurrence, and then we need to find our something that sometimes is needed and sometimes is not, is how are we going to, like in what order are we going to iterate, in what order to iterate. This is a useful question to ask in dynamic programming problems. Sometimes this is obvious, but sometimes the way you order the iteration, like whether you start I from the beginning or from the end of the list, makes a difference. So that's important to think about. So what is our goal function here? We want the longest palindromic substring, right? The goal often hints at what is the state that we should use. So I forgot to mention we need to find the state also. And so basically the state is DP at something, right? And so here we want substring. So whenever you see substring, that means we need two boundaries. We need I and J, the start of the substring and the end of the substring. So here it can be just, our state can be longest palindromic substring starting at I and ending at J, right? To identify a substring, we need these two indices, right? And so what is our base case then? So here basically we would have dp of I, J, which would be our state here. So the base case is for any string, for any character, dp of I to I, that's just one character, and our dp here is going to be, so one thing that I forgot to mention is this has to be the whether the substring starting at I is a palindrome, right? That will help us more because once we find the longest, we no longer we no longer care about anything else, but what we want is to find whether a portion of the string is a palindrome. So if we find, let's say we have, so let's find a long palindrome. Okay, let's see, for example, let's say we have this, ignore the space for now, TacoCAD, which is taco, in the reverse it's the same thing, right? So for this one, we need to find if, so this substring here from C to this one, that's a palindrome, right? And so knowing that this is palindrome tells us that if we find the neighbors are palindrome, then that means the entire substring here is a palindrome. And so the information that we need, that a substate needs from another state, is whether it's a palindrome or not, right? And so that's what we will be encoding here. And so just A by itself, or T by itself here, that's a palindrome, right? Because it's just one letter, whether you read it from left or right, it will be the same. And so that's true, right? And also we know that I to I plus 1, this one is a palindrome if, of course, only if Si is equal to Si plus 1. Because if you have AA, that is a palindrome, right? That's the only case you can have two letters palindrome. If you have them with different letters, there is no way for it to be a palindrome, right? So that's another base case. Now, how can we determine our recurrence? So a dp of ij, how can we write that in terms of, as a function of dp of what can be, so for a substring, what can be another case that it can depend on? So if we have, let's say, I here, and let's say j here, or let's say I here and j here, what do we need to know? Which thing helps us? So it helps us to know whether this here is a palindrome, because if it's a palindrome, we can just check if these two characters are equal, right? And so we need to know the state I plus 1, which is I plus 1 is this character, and ending at this character, which is j minus 1, we need to know whether that is a palindrome, right? And so what can help us is knowing whether dp of I plus 1, j minus 1 is a palindrome, right? So if that is a palindrome and Si is equal to Sj, then we can immediately say that that it's a palindrome, right? Because in this case, if COC is a palindrome, which it is, then checking that A equal to A, that means whether we read this way or read this way, it would be the same, right? And so this is the recurrence that we need. And the other thing we need to do is keep track of the max length palindrome found so far, which means that whenever we found if dp of I j is true, basically, then we need to say res need to be equal to we need to check also that it's max. So we need to check that the length of the longest palindrome we have so far, which is the length of res, we need to check if that is less than the current length of the substring starting at I and ending at j, which is just j minus I plus 1. If it's less, then that means we have a new longer palindrome, right? Or a palindromic substring. So we need to replace that, which is just saying I to j plus 1, because in order to get to j, we need to do I plus 1 with Python's indexing, basically. Okay, now let's go to the order thing that we mentioned here. So let's say we have this substring here, right? And this position here is, let's say this position here is n minus 1. And so if we start the normal way that we usually start, which is saying I from 0 to n, and then j from I to n. This is, most dynamic programming solutions have this structure, right? If we do that, the problem is we would start like this, and then we would advance j, but we have no information about this because we haven't visited yet, so we need to recompute that. And then we don't have any information about I plus 1 and j minus 1 because I is still at the same position, and so that won't help us. And even with that, we'll keep going. And so whenever we find that this structure doesn't help us, we need to think, okay, let's just go from n minus 1 down to 0, and then j from I to n, and try this structure and see if this structure helps us more. And so this structure would mean we start out with this j at n minus 1, and then I at j starts out at I. So we check this first letter. If it's a palindrome by default, the next step would be moving I here, right? And now we know this information, right? Because we already computed it, right? And so we just need to check the current letter if it's equal to this one. And that way we know whether it's a palindrome or not. And then when we advance here, we already have that information about this character. So we need to just check this one. And then if we move here and move j here, we already know whether this is a palindrome or not, right? And so I plus 1, we already have the information about I plus 1. And if we move j here, we already have the information about I plus 1 and j minus 1, right? And now if we move here also, we already have the information about I plus 1 and j minus 1. And as you go along, you will have the same thing. We structured the loop in a way that when we each time we will already have an information about this subproblem that will help us solve it. And so that's something to keep in mind. Now let's implement this solution. So we need a DP that of Boolean, and so that would be something that starts out with false, and then let's just say n is the length of our string, and multiplied by n, and then this is for all. So it's n by n array, right? A range of length of s, which is just n. The second step would be to say, okay, let's keep track of the result that we need, right? So that one starts out as just an empty string, and then we need to do the loop that we just said. So I in range of n minus 1 and minus 1 and then minus 1, and then we need to have for j in range of I to n that we said here, and we need to do the recurrence, right? So the recurrence is this that we said here. So if then at that point our ij is equal to true. And another thing that we need to handle is this base case. We can handle it separately, but another way to handle it is just, so if if j is equal to I, then at that point we would be checking si equal to si, so there is no harm in doing that. But we can't check this because I plus 1 and j minus 1. So let's say, for example, for cases 0, 0, if you check I plus 1, j minus 1, you would be checking 1 and minus 1, which doesn't make sense. So we need to check here if j minus I is less than 3, or because in this case it's by default true, right? So either it's that j minus I is less than 3, that means that either j minus I is equal to 2, or j minus I is equal to 1, right? So if it's equal to 1, that means they are equal. That means that means we have 2 minus 1 or something like that. So that means there is a difference of 1 between them. or it could be like that the difference is 0, right? So in all these cases, either I is equal to, either it's just A, for example, which is, we will be checking Si equal to Si, so it's by default equal to true, or it's something like this, because Si equal to Si plus 1, because the difference is just 1. And in that case, it's still dpij is equal to true. That's correct. Or it's something like this and another letter. So when the difference is 2, then it's something like this, because when we check I and j, we'll check the boundaries, right? And so we'll check these two, they are equal. And so no matter what letter we have in the middle, that's a palindrome, right? And so we set dp of ij to true for that case. And so in all cases where j minus I is less than 3, we have and the start and the end characters are equal, then we have dp of ij equal to true, as we listed in the examples here. Now we need to do for res what we said here, and so that would mean something like this. Or for the first case, when length is 0, so we don't care about whether it's less or not, we want to replace it. So we can do that doing this, doing or. And that's pretty much it. And at the end, we need to return the result. Okay, so that's pretty much it for this problem, for this solution. Let's submit. So we have oh, equal actually. It should compare. Okay. Let's test with the stronger case like this one. Okay, so this solution passes, and in terms of complexity, time complexity here, we have it's O of n. So you can see here we are doing n iterations, and then at most n iterations after that. So it's O of n squared overall. And in terms of space complexity, we are using also just this array, which is O of n by n. So also O of n squared in terms of space complexity. Okay, so that's pretty much it for this solution. Now let's see another way to solve this problem. So another way to think about this is, instead of what we were doing here, where we started from from some end and we kept iterating backwards in our DP solution here, and kept iterating until we got to the start, and each time checking the max. Another way we can solve this is we can start at the middle and expand and just put pointers left and right. So do something like, let me just put spaces here. And so put some index I in the middle like this, and put some indexes and start expanding around that index. And so I'll start here and we'll check if these are equal, which means we are still in a palindrome. Otherwise we do, let me just, maybe it would be easier if we do this down here and left here, right? And then just keep, these are, C is equal to C, so which means we can expand more around this here, and so we expand here with L and expand here with R, and A is still equal to A, so we expand again and until we get, and so we keep expanding until we no longer find characters that are matching on both ends. So basically keep expanding until SL is different than SR, or we reach the boundaries. And since we are starting from the center, we will know that immediately. The only problem is that, so this string here is of odd length, right? So this is very easy with odd length, since we have only one center, right? But what if it's of an even length? So if it's an even length, like let's say palindrome of even length, maybe let's take, for example, BA, AB, let's say something like this. So that would be 3, 4, 5. That's still not. So this one is even length because it's 3, 6. Yep. So let's take this letter, this string here, right? So the problem is we can't, if we do just have this, do the same thing. So the center, where is the center? We don't know, right? And so we can just do something clever, which is take this I and I plus 1 and take both of them as the center, right? And then what that means is that we can just put L here to the left of these two and put right here, right? So we need them to be equal, right? For that to be, for it to be even considered a palindrome. And then after that we can just keep doing the same expansion that we did here, right? And keep doing that same expansion, and keep going until, keep expanding while keep going through using this rule, right? So that's pretty straightforward. And so once we do that, so every time, because we don't know the length of the palindrome, we don't know whether it's of odd length or even length. So even length, we have 2 centers. So we don't know whether it's even for every potential palindrome. We don't know whether it's we don't know beforehand whether it's palindrome or not, whether it's of even length or odd length. So what we do is we just check both, right? Check both which means with one center and 2 centers, and that's pretty much all. And take the longer one, because what we are looking for is the longest palindrome, right? Palindromic substring, right? So let's do that. Okay, so let's start considering every possible I as a center, or I and I plus 1 as centers. And so first we handle the odd length case, and then after that we handle the even length case, right? And we need the function that expands from the center and keep checking these. And so let's call that function just expand from center. And that function will need the string and 2 boundaries, L and right, left and right. That start out for the center case, they both start out here. They both start out at the center, but then L moves to the left and right moves to the right. For the case where we have I and I plus 1, L starts out here and L starts out here at I+1, and then they keep moving. L to the left and right to the right. And so to do that, we already have our expand from center that expands from left and right, and then we need to call it for S at I. So this is the case where we have one center, and this is the case where we have two centers. So for the case where we have two centers, we need to pass I and I+1. And so for the first one, we will get the first string, which is the palindrome that we can get by expanding from the center. At least it will be one letter, which is the center. And then here we'll get the palindrome that expands from both centers, which at least would be one of the letters, because at least that's a palindrome, right? And so once we get these two, we will check which one of them is longest, because that's the one that we are interested in. And we are guaranteed that this here will give us only a palindrome, right? So this function should guarantee to return a palindrome. And so we can check the length here, and so that would mean that our result is going to be the max of S1. So let's call it this P, the palindrome. So it's max of these using the key length. So the bigger one of both in length. That's what we are interested in. And then we want res to replace to be the max of the previous result, and the new result use whichever one is bigger in length. That's the longest we are looking for. I could use if here, but this is just nicer. And at the end we can just return the max res we found. But max in Python supports multiple parameters, so one thing we can do is just, instead of calculating res in advance, calculating P and using that to find res, we can just do one operation like this and take the max of all of them using the length, because that's what we want, right? And then we need to write our expand from center. So we need to keep expanding while we haven't reached the boundaries, so that means 0. So I'm just going to apply this, what I said here. And R is, of course, less than N, or the length of S. And we still have a palindrome, which means SL is still equal to SR, right? So if all of these cases are valid, we need to go left with L and go right with R. And then at the end, we need to return whatever palindrome we have. But one thing we should keep in mind is that for the last operation where we find this is equal, we did go left and right. And then in the second operation, maybe this one failed. So, or this one failed. So in order to get the right palindrome, because we overcounted or over decremented and over incremented here, we need to increment by 1 this one to compensate for that. And we can leave R like this, because this here is equivalent to going until R minus 1, which means we decrement and compensate for our over incrementing here, and we return that. And that's pretty much it for this problem. So let's run this. Okay, I didn't return res here, sorry. Okay, so that solution passes. Let's try with one that has an even length, like this one. Okay, so this solution also passes. In terms of time complexity, this is, so here we do n steps, right? So here we do n, right? And the expand from center also goes through at most the entire string, so it also does n, right? And since it does, there are 2 of them, so overall it's 2 n's, right? And so since overall it's 2n, that means that here we have n multiplied by 2n squared, 2n, right? So the overall time complexity is O of n squared, right? it's O of 2n squared, which roughly is O of n squared. In terms of space complexity here, we are not using any extra variable really. We are just using these S1, S2, and res here, and left and right pointer. So mostly we are using constant space variables here, just variables, so just constant space. And yeah, so that's for this problem. We saw how we can solve it starting from brute force, improving upon that brute force by making it return the longest, likely to return the longest palindromic substring first as early as possible, and then we saw a dynamic programming solution, and now we saw this solution that kind of expands from the center. And so one thing to note for this solution is, why does it work? Why does it give us the longest? One thing is because it does this, it checks for the longest and each time puts that in the result, but also it expands as much as it can, right? It keeps expanding until it can't no more, right? So we will go as far as possible for each center, which means that one way or another, because of using this, we will find them, because we go through all of them. We go through all the possible centers for the palindrome. And so by definition, we will end up finding the longest palindromic substring. And yeah, so that's it for this problem. Thanks for watching. See you next time. Bye.